Alright, now let's go on with problem these guys. This will be done later on when we go with XORs and stuff, and it's very simply provable with the truth table, so I'm not going to bother with that one. This one I'll do, and sure, this one's hard. Yay! So let's start with 1.14. How exactly do you do this? I have no idea. Just kidding, I know. But how do you prove that? Well, he always said work with the complicated side and make it simpler, so we'll work with the left side. Now, what rules can we apply to this? It's very hard if you haven't memorized the cheat, well, the cheat sheet, not the cheat sheets, I guess the laws, and I'm not a good student, so I have a cheat sheet. So let's look at something that gives us something. So oops, this is called the fetal. I have no idea why this page is called the fetal, but let's not worry about that. This kind of looks like x plus yz, right? They're all different characters. I guess this can be x naught, but hey, it can also be z, whatever. Alright, so let's look for something with this format, or something similar to that. X plus yz. X plus... Hey, I kind of cheated, but hey, this guy looks like it. So it becomes x plus z, y plus z. Alright, sure. X plus z, y plus z. So it becomes b plus z naught, and it becomes... What was it again? Goddamn. X plus z, y plus z. X plus z, y plus z. X plus z, y plus z. Right? Now, from here, we can't really do much to this, but this looks identical to this guy. So we clearly know that we have to work with this. Well, this will actually always be 1 or true. And how do I know that? Well, 1 from logic, because if C or C naught, since this can either be 1 or 0, and C naught will always be 1 or 0, corresponding like that, it has to be 1. And if you don't know the logic like that, there's also something on the cheat sheet which says, where's x plus x naught 1? There you go. That one will always give you 1. Because of that, you know that this will just be b plus c naught. Yeah, they give you a nice and easy one to warm up, and then they decided to give you 1.15. This one's really confusing, and it seems like things are appearing out of nowhere, but I'll try to be as thorough as possible, and we'll probably need a lot more space. So I'll just do it over here. 1.115, and you have prove a b plus bc plus ca is ab plus ca. Let's see if my memory serves me right. Yep, alright, cool, I got it. Oops, it should be right here. There we go. Alright, again, work with the more complicated side and narrow that one down. So, left hand side, I'll just start over here. Left hand side, ab plus bc. Sorry, it's not plus, it's ors, but I'll just say plus because it's so much easier. Alright, let's work with that. Well, from here on, we can factor these guys, I guess. Well, that will do nothing. We can factor these guys, but again, that will give us absolutely nothing. Now, this next step is not intuitive at all if you started Boolean Algebra, and it took me forever just to even come up with it, and I didn't. I gave up and looked at the slides. But hey, I understand it now. That's all that matters. Next step, what you do is, remember, when you have x plus y, same thing as saying a 1x plus 1y. That concept gets applied here, and you just imagine there's a 1 in front of bc. That changes absolutely nothing, right? But it makes everything. So, since that, you can actually make the 1 a or a naught. And the reason you can do that is because as explained by 1.14, this will give you 1. And hence why we did 1.14 beforehand, just to use this rule. And exactly why are you doing it? Well, now if you actually distribute this, you'll have something that's factorable by both at the same time. The problem before was you can either factor from this guy or this guy. But once you distribute the a and the a naught out, you can factor with both of them, right? Because you can factor this with that and that with that. So now thinking about it like that kind of makes sense. So why don't we go ahead and distribute that? ABC and a naught BC plus, oh, that disappeared. Right. So, you're like, okay, I just talked a lot about factoring. Yeah, you can factor. But thankfully, we have the simplification rule, which states that x plus xy will give you x. Now, if you can't see it yet, I'll highlight it. And you guys see that? Well, hopefully, because it's bright yellow. But since this is x and this is x, y, and this, well, these two make x and this makes y, and this is x, you can actually just simplify this straight to ab plus a naught c. Yeah, cool.